Hello, everyone, and welcome to DZone's virtual roundtable on the 2025 Kubernetes Trend Report. I'm Corey Knowles, and I'll be your host today. Over 170 software professionals shared their experiences in our latest survey, and today we'll unpack the findings. We'll explore Kubernetes adoption trends, workloads, developer experience, tool change, cost optimization, observability, AI, and security. We'll unpack what the report revealed, but more importantly, we'll get some firsthand insight. I'm excited to introduce Dan Cerulli. Dan is the Vice President and General Manager of Cloud Native at Nutanix. How you doing today, Dan?
I'm doing great, Corey. How you doing?
I'm doing great, man. It's good to have you here and excited to get this rolling. About 77% of organizations run Kubernetes clusters, unchanged from last year, with web apps around 92% dominating workloads, while CPU-intensive use has declined from 67% to 54%. Large organizations lead adoption, and small organizations are lagging. So I guess to get us started here, is Kubernetes now table stakes rather than an emerging trend, or are we entering a phase of consolidation?
It's definitely table stakes at this point. There are. It's funny when I hear a stat that 77% of organizations are doing it. I always wonder about the stat, and is that across everything? Is that enterprises? Are there a lot of small ones who aren't? Because in reality, almost every workload that's being developed and deployed today is being developed to be deployed in containers, and almost all of those containers are being deployed in Kubernetes. You don't find people who are using alternative deployment mechanisms for new development, and so it's not surprising that we see close to 80%. In reality, I think it's probably a little bit higher than that. I can see there being a small sliver that aren't. So yeah, it is pretty much getting to be table stakes. Now, the interesting stat that is a lot harder to get at is what percentage of the workloads are running in Kubernetes, because that number, I will tell you from my anecdotal experience, that number is still growing and will continue to grow for the next probably decade.
Wow. Yeah, and Kubernetes is in everything now. It's very, it's gone from being the trend to being the way it is.
Yeah, I mean, it's just a better experience, and the fact is, the companies that adopt it, regardless of what sort of industry they're in, they end up doing better, right? I always say every technology is now a technology. Sorry, every company is a technology company, and the ones who are using Kubernetes to deploy, they're innovating faster, and that's what it all boils down to. So that's why we see it's just in everything now.
Yeah, absolutely. So what does the workload shift toward web apps and away from CPU intensive applications suggest about the Kubernetes sweet spot?
That's an interesting one for me, because I haven't experienced that distinction personally. I still see broad adoption. It might be that people are kind of drawing a distinction in a way that I'm not sure makes that much sense. And let me explain what I mean, because almost every application we use today has a web interface, right? It is the default mode. You're either using it through a website or you're using it through a mobile client, right? In the end, though, there's a backend, and that backend is typically being deployed on Kubernetes. There are a small number of scientific workloads who are using something like Slurm for which is an open source high performance computing toolkit, but Slurm adoption is definitely not going up. So I take it with a grain of salt when I hear someone that number, especially going down dramatically like it did. I doubt we're actually seeing that in real life.
That makes sense. So developers report both benefits like improved scalability at 57%, for example, and challenges like a higher learning curve, 47%, or complex debugging at 43%. Large organizations, though, saw faster release speeds, while about half of organizations offer an internal developer platform, and those that do report better outcomes. So, from your experience, how do you help teams navigate Kubernetes learning curve while still unlocking its scalability?
It's pretty tough. There's a lot to the learning curve. That is no joke. That has been I've been involved in the cloud native landscape pretty much since the beginning. My time at Google, I was at Google Cloud as these technologies were being developed, and since the very beginning, we've been talking about that learning curve. Now, in a lot of ways, it's improved, but it's still very complex. And really, what it comes down to is a few different things. First of all, Kubernetes can be complicated to run.
Hmm.
And you need a team. We'll get more into the IDP, the internal development platform, but you need someone who's running those Kubernetes clusters. They need to be trained up. But then the
Hmm.
developers too need to think differently. They don't need to be trained on Kubernetes, so to speak, but they do need to think about how they are building an application that's going to be deployed as microservices. And there was a good 3-4 years where you couldn't turn around without bumping into the words microservices. We're not
Yeah.
saying it so much anymore, and that's okay. But the fact is that applications that are written to be deployed in containers often have communication between different containers, right? You have all these
Hmm.
API calls. When it's time to debug something, you're not just looking at one chunk of code. You have to look at the chunk of code you wrote and the chunk of code that's calling it, but maybe somebody else wrote, and the chunk of code you're calling that someone else wrote. Determining where the issues are there is difficult. Now, there are some things that can really help. I worked for a long time on a project called the Istio project, and one of the real benefits of a project like Istio is it allows people to visualize and log, if they want to, literally every call in that chain and say, okay, I can see the service dependency graph of my application. I can see what's calling what, and maybe you're trying to track down, why things are running slowly. You can literally visually see, I can see what happened. I'm calling this other service. That thing is talking to the database, and that connection itself is adding latency to my calls. So in some ways, having the right tooling in place can make the developer's life easier. But if they're coming from a world in which they weren't using Kubernetes, they weren't developing microservices, they didn't need to think about a project like Istio that would give them that visibility, they didn't need to do it. They could do it all in one live debugger on their laptop.
Which was way simpler.
It's way simpler, right? Now, I've heard some companies who have really interesting tooling for this. I talked to a company who had they were actually, won't talk about Istio the whole time, but I remember talking to them about it. They had a test cluster where all the services were running a copy of every production microservice. And when a developer did a deployment of something they were testing, they could deploy and run the app so that the production services were getting a hit for everything, not on production data, by the way, but the production copy of the service for everything except their individual microservice. And it would allow them to test that their part was indeed working, and would allow them to debug if there wasn't, without affecting anyone else. So there are companies who are certainly putting in place in their IDP infrastructure that can do really cool things to make it easier on developers.
Wow. So, what features of an IDP make the biggest difference in reducing friction for platform engineers and developers?
So I think for both, the keys are automation. You to make an internal development platform work well, you need to automate every single thing you can. And when you look at early adopters of containers, and I think back in my own time at Google,
Hmm.
what made Google really effective, this was not Kubernetes. They still don't use Kubernetes internally. They use a system called Borg, right? It's all internal. But what made it successful was the amount of automation that went in. Because when it comes down to it, you want a developer to be able to write a piece of code and then see if that works.
Yeah.
And everything from how that code gets containerized to how that container gets deployed into a test system, how traffic gets, maybe simulated, launched, all of that needs to be automated. And the companies that put effort into that automation so that the
Mhm.
developers get as close to I wrote code, it got deployed automatically, tested automatically, and then maybe promoted through the system to deploy to production automatically. The more work you put into automation, the better. And the same thing goes for the platform engineers. They're going to be doing things like building Kubernetes clusters. They're going to be upgrading Kubernetes clusters, changing the size of those, maybe dynamically, according to load. Everything that they do, similarly, you want to get as automated as possible. There was a very famous graph in my time at Google that Eric Brewer, who is he's a professor at UC Berkeley, eminent computer scientist, but also works down at Google, and he had this graph that showed the number of services, production services running over time at Google, and it was just this curve up, incredible number. When I left, and they've talked about this number publicly, it was over 400,000 running production services, right? That's more than, that was over 4 per employee. What was interesting is that the number of people in operations did not follow that same curve. It went up linearly, while that curve was growing exponentially. And the reason a linear number of people was able to keep up with an exponential number of services was the effort that they put was in automation so that things could scale.
Which keeps getting more and more accessible.
Right. And what that fundamentally means is now your developers are able to innovate at a pace that no one else can. If you think about the early 2000s, when we were stuck in Alta Vista land, right? And Hotmail at the time, think about the highest quality of anything when MapQuest, right?
Yeah.
Think about what Google did in that 5-8 year period when they were really one of the few companies using containers. One of the big secrets that they had was they were able to innovate so much faster than everybody else. And literally containers played a big role in why they were innovating so much more quickly.
Wow. It's not a thing I'd ever thought of, but that makes so much sense.
It's really fun to look at it in that way.
It is. So if an organization doesn't have an IDP, what are some lighter weight practices or tools that can still help IT teams and platform engineers?
Well, there's certainly the easiest thing to do is don't start from scratch. Starting from scratch on an IDP is really difficult. And, in the cloud, using Kubernetes is fairly easy, and it's easy to automate around. You need to spin up a cluster automatically on any of the clouds. It's just an API call away, and do it with an API call, right? Don't have the standard procedure when someone wants a Kubernetes cluster to have someone go click a button somewhere, right? On premises, there are a few different enterprise vendors who can help out and give your platform engineering team that starting line. I work at Nutanix, our product, Nutanix Kubernetes platform. Essentially, that's how customers use it. Starting at someone else has already written a bunch of the automation, has assembled a bunch of the pieces, really gets you as a platform engineering team really far along, saying, hey, this is our IDP, right? And now we're going to put effort into a thing because we kind of got that, more than halfway there out of the box. The effort that we put in won't be building scaffolding, right? Now we're going to be furnishing apartments effectively in this building that is our IDP.
Saving you months of work. Compared to what it would be manually. Yeah.
And it's not only that, it's not only saving you months of work up front, it's saving you, person months of effort every single year. As you build that scaffold, you're in charge of maintenance on it, right? You've got to figure out, hey, what do we do when it's time to upgrade Kubernetes? That's complex, right? My buddy Kelsey Hightower wrote a book on installing Kubernetes. It's Kubernetes the hard way. Literally, right? So don't put your effort into that. Don't put your effort into upgrades. Let someone else take that on so you can figure out, okay, what makes us unique? What makes our organization unique? What's going to work for our developers to get them as productive as possible?
Makes sense. Spend your time on what's important. So most organizations use 3 or more container tools, with Docker Kubernetes usage rates falling year over year, 45% report tool sprawl. Biggest challenges, though, are maintenance at 50% of people and integration around 39%. On costs, though, 90% optimize in some way, with containerization, CI/CD, automation leading, though. But collaboration feedback loops fell sharply since 2024. With that, are we at the point of Kubernetes tool fatigue, and how should teams prioritize toolchain consolidation?
It is a good question. I think one of the benefits of deciding, hey, we're going to build an IDP, there's no firm definition of what an internal development platform is. But one of the benefits in pointing to a team and say, hey, you're going to build our IDP, you're in charge, go do it, is that you give them the freedom to standardize. And that standardization can really help. It really bothers some people because, some developer will be really attached to some particular tool somewhere in the organization, will really feel like, hey, you're hampering my productivity if you standardize and you tell me what, you name it, service mesh I'm going to use or observability stack, whatever, it doesn't matter. But in fact, by doing some standardization, what you're doing is you're saying, hey, all the different 50 teams using Kubernetes here, you're not going to put time into making these decisions. We're going to give you something that works out of the box, and you're gonna go from there. And then you get teams that are focused not on, hey, let me choose the best tool for this particular Kubernetes minutia. Rather,
Yeah.
they're saying, okay, I'm going to be writing code that helps our business, right? If we're in
Yep.
insurance, I'm going to be writing that insurance app. I'm going to be making that app better. So that standardization is really, really a big deal. And that's one of the primary benefits of an IDP. There are a lot of others, because when you do automate, when you do standardize, it helps you in security. The easiest
Yeah.
way to get, and I don't want to claim security is easy, but the best way to get security rules to actually be followed is to automate all of it, right? If you want container scans, don't tell people you have to run a container scan before you deploy. You have automatic container scans before deployment, during deployment. You want to get even better, shift left and have those scans happening during the build process. Have you're actually looking at your dependencies before the build process. So the more you can automate, the more secure you get, the more you end up with developers actually spending time on the business problem at hand. And yes, the more opportunity you have for cost reduction. And I think we can even dive in there a little bit more.
Yeah. So why might collaboration practices for cost optimization be in decline? And is that a thing that's concerning?
Well, it's certainly concerning. Why might they be in decline is a little bit tough to say, and I don't think that the numbers from a survey can tell us. Absolutely, it should be concerning, and the reason it's concerning is that most of the savings that people get from cost optimization in Kubernetes, and huge chunk can be because they just set limits wrong. Right? They're deploying an application that needs a quarter of a CPU, and they're asking for a full CPU, and no one ever checked it. That is by far the biggest thing that can happen. And there are a bunch of different tools out there. We have different partners like Densify who can automatically look at a cluster and compare how much our capacity are people reserving and how much they're using, and then automate fixing that. Right? Little things like that can really, really help. But if people aren't collaborating on that, if they're having a problem, I would say the problem that goes back to that tells you a problem with the IDP. Because again, that's something you build into the IDP. It is not a good idea to have as part of your development process. Okay, now go do some things to figure out what your right capacity reservations and limits should be, and then go set them. No. That should all be automated, so the developer can't make that mistake, and it can't end up costing you, hundreds or thousands of dollars extra per day, week, month.
Yeah, it racks up fast. Well, while we're
Incredibly fast. And when you're talking, I talk to organizations who are running hundreds of Kubernetes clusters. If they're all over provisioning, well, then they're just overpaying. There's no doubt about it.
yeah, it's just throwing money away.
Yeah.
Well, let's talk a little bit about observability and AI. So 92% use at least one observability tool, with Grafana, Prometheus leading. About half use AI for observability, but adoption hasn't grown. Only a third run AI and machine learning workloads on Kubernetes, and those that do are more likely to use AI and observability. So why has AI adoption for Kubernetes observability kind of plateaued? And what does this signal about its value or maturity?
I think that AI around observability is still, I would say it's still nascent. It's still growing. I
Yeah.
see some companies doing really interesting things. Just talked to another partner of ours called Commodore, who's doing some
Mhm.
super, super cool stuff. It is very, very cutting edge. I think maybe there was a lot of hype. By the way, you name nearly any industry today and say, hey, was there a lot of hype around AI in that industry and how much has it changed? And you're going to get the same answer, which is, well, we know it's going to impact it big. It just hasn't happened yet. And I think that this is a case exactly like that we will see really interesting things. We talked earlier about the learning curve around Kubernetes.
Mhm.
I'd fully expect that AI and machine learning and the advances there are going to be one of the things that helps solve this learning curve, right?
Mhm.
And
Mhm.
I liken it to what it used to be like to own a car. And I got my driver's license in the 1980s, and back then almost every car had a carburetor. You could open the
Yep.
hood on a car, you could look at the spark plugs, you could see, pull those cables on the carburetor. You could make minor repairs. You had to understand how a car worked, really, right?
Yeah.
Nowadays, cars don't work that way. They are maybe this is a good analogy, self-driving, right?
Yeah.
You don't need to do that. You don't need to do a tune-up. A computer is constantly doing that. Think about that. There's a great
Yep.
analogy. A computer is constantly tuning up your car, right? AI
Okay.
is going to do that for Kubernetes. You
Mhm.
will have a computer constantly tuning up your Kubernetes cluster. And yeah, it's going to be using AI. It's going to understand, oh, that metric is changing. We got to do this. Oh, I can see that thing needs, a slightly larger reservation. We're going to do that. We need to, those two workloads don't cooperate. Let's put a taint on one or create a different node pool.
Yeah.
AI is absolutely going to assist in all of those things. And by the way, all of that is dependent on great observability. So you need, whether
Yep.
you're using Prometheus Grafana stack, you're using something else, that process that is helping you run your Kubernetes cluster is absolutely going to need access to all that, because that will be, information is the lifeblood of any system, and that's the information that it needs.
Yeah. Yeah, that's absolutely true. And observability is, I, I can't count the number of conversations I've been in over the last 2 months specifically, where it's been a subject people are talking about and trying to understand and what it means for not just the AI space, but all of these other spaces in engineering that are going to be impacted by that, and why it's vital. And it's not been an easy fix.
No,
But
no, no. But you can't improve something if you don't measure it. And
that's
so
right.
you measure everything and you figure out ways to improve it. And, at the very least, you want a dashboard that's alerting you when there's a problem. But as technology improves, then that same data is going to be fed into an algorithm. And that
Yep.
algorithm will detect a problem that you don't even know about. And eventually we'll fix it before you know what's going on.
Absolutely. Absolutely. Well, I have a question or two about security here I'd like to ask as well. So, most organizations layer multiple defenses. According to the report, 70% update Kubernetes regularly, 57% enable RBAC, 53% restrict ports, and still 31% reassessed production deployments due to security concerns in the past year. So larger orgs are running lean on service meshes, while mid-sized companies are emphasizing updates and privilege controls. And I say that to ask, if most orgs are following best practices, why are so many still halting deployments over security?
Well, the security space is evolving just as rapidly as the rest of the ecosystem,
Yeah.
and in fact, maybe a little bit more rapidly. And the reason is that we live in a society in which there's more data than ever. There's more, we use apps for everything now, technology for everything. There's
Yeah.
more and more reasons for hackers to want to get in and mess with things, right? And by the way, hackers are smart people. They are constantly evolving. They are finding ways around. This will be a never ending battle for sure, and it is it is, as important as ever and will never stop being critical to paying attention. What is the latest way that attacks are happening and how do we stop that? And so, yeah, we see, you said, almost everybody is doing multiple levels. Well, they better be, because the space is changing quickly. We see really interesting things happening from, supply chain security. This some old coworkers of mine started this company, ChainGuard, that has invented essentially in this industry and secure supply chain. How can we make sure that the containers we're deploying are secure, right? And can we build them from source and ensure that there was no malicious code got in, right? All the way through service meshes, allowing you to put MTLS on every call, even if it's staying within your data center, even if it's staying within your cluster, right? Zero trust networking, so you get encryption all the way out to the edge and back, and you're not dependent on that firewall. But yes, you do want that firewall in there. So the attackers are never going to stop innovating, and our defenders never need to stop innovating. I actually heard a really interesting. I was talking to someone in the Department of Defense who was talking about their Kubernetes adoption, and he said the people who are trying to break in, they're innovating really, really rapidly, and that's what keeps me innovating really rapidly as well. And when the DoD is making that clear, I think it should be clear to everybody.
Exactly. Something we've joked about in AI is that, the hackers get new tools at the same time the companies do. So as the new toys come, they both get faster.
Absolutely right.
Well, let's thinking a little beyond the basics. What are the most impactful next level Kubernetes security practices?
Well, I'll say it's all the above. If I could recommend one thing, it would be, because you do need all those levels, and I kind of hinted at this early, but I'll say it again. The automation is the key here. Do not ever depend on individual teams to make the right decision for security. That should be first and foremost something that is built into that IDP. In fact, almost 10 years, maybe not 10 years, but 5 years before I ever heard the term IDP, I remember talking to a company, really interesting. They run a website in the United Kingdom called Auto Trader. They're in the United States as well, but I was talking to their UK group. They needed to put MTLS on their system-to-system calls as part of a contract they were getting. They weren't using Kubernetes at the time. They were actually using VMs, but they had incredible automation. Their developers would check in code would get packaged into a VM, a machine would get spun up automatically, and that code would deployed. But they couldn't get MTLS working. They decided, well, the easiest way to get MTLS was this new project called Istio. And the easiest way to run Istio was on this thing called Kubernetes. And the easiest way to get Kubernetes was to deploy into the cloud in Google Kubernetes Engine. So their platform engineering team, again, they didn't call it that back then, but that team who had built their automation pipeline took that automation pipeline and they said, okay, instead of VM images deployed into our data center, let's change that pipeline so the output is a container in a Kubernetes cluster in the cloud. And that company adopted Kubernetes without telling the developers. And they got MTLS out of it. So that's and now now, by the way, they're 100% on Kubernetes, 100% on cloud, but their adoption was easy because they had fantastic automation built internally, and they were able to implement something like MTLS on every call because of that automation. So that really is, if I'm getting back to your question in security, I didn't forget that the number one thing you can do is build it into your IDP so that your developers aren't making any choices around security.
Wow. Well, Dan, thanks so much for all of the insights today. It's been fascinating.
Well, listen, I love to talk about this stuff. I love to look at guitars. So I will join you for one of these conversations anytime, Corey.
Awesome. Well, today's discussion highlighted how Kubernetes has matured into critical infrastructure, but also how complexity, cost, observability, and security remain active frontiers. We'll make the full Kubernetes Trend Report available for our audience, and we encourage you to dive into the details and check it out yourself. Thanks so much for joining today. We'll see you next time.